Hey guys, today's video starts our unit of exponential and logarithmic functions. And the topic today is the meaning of logarithms. So logarithms and exponential functions are inverses of each other. One undoes what the other one does. And so we're going to take a look at this log function. Y is equal to the log of x base A. And that's how you say that. There's two ways to say this or to read this. You can say that this is the logarithm base A of x, or the log of x base A. Okay? And essentially what that means is A raised to what exponent will give you x. Okay, so a couple things we kind of want to note here is that A is our base, Y is our exponent, and x is our argument. So A raised to what number or what exponent will give us, our argument will give us x. And we're going to apply that in a couple of the examples. But first I want to show you that this equation is basically what we're saying over on this side. A, the base, raised to what exponent, y, is equal to the argument x. So let's use this to solve or to rewrite the following equations. Their base is 6, our exponent is 2, and our argument is 36 here. So how to rewrite this? We're going to rewrite each equation in exponential form. This is exponential form. This is logarithmic form. Okay, so we want to take this and rewrite it like that. The base 6 raised to what power? 2 is equal to 36. 6 raised to what power gives us 36. 6 raised to the second power gives us 36. Okay. Now let's work with our second example. Okay. So we have 289 raised to the 1/2 power, supposed to give us 17. Okay, so this is the logarithmic form. We want to rewrite it as an exponential, in exponential form. So 289 raised to the 1/2 power is equal to 17. Okay. We have two more. 14 to the -2 power is equal to 1 over 196. And then this one, the log of 81 base 3 is equal to 4. We write that in exponential form as 3 to the 4th power equals 81. All right, now we want to take this and let's recall that these two equations are equivalent. Okay, meaning they're equal. Here, what we're given is we want to evaluate each expression. In other words, for this, we want to find y. This is where we're trying to find the exponent, right? We're given, this is the logarithmic expression, right? This is an expression because it does not have an equal sign here. But we want to evaluate it, so we want to find y. Okay? This is a logarithmic expression, and we are wanting to find y. Okay, so 4 raised to what power is going to give us 64, right? The what is going to be y. Okay, So if we were to finish writing this expression, this is what we would get. 4 raised to what power gives us 64. 4 raised to the 1 power is 4. 4 raised to the second power is 16, so 4 times 4 is 16. 4 raised to the third power, 4 times 4 is 16, times 4 is 64. So this means that y is equal to 3, okay? So 3 is our answer. 6 raised to what power will give us 216? 6 raised to what power gives us 216? 6 to the first power gives us 6. 6 squared equals 36. 6 cubed gives us, so it'd be 6 times 6 is 36 times 6, right? Well, 6 times 6 is 36, and then we have a 3, so we have 6. 6 times 3 is 18, plus 3 is 216. Y in this case is going to be 3, so 3 is our answer here. We have 2 more down here that we're going to do. 3 raised to what power gives us 1 over 243, okay? Well, let's see. Right now, what I'm going to do is I'm actually going to ignore the fact that this is in the denominator, okay? I'm going to ignore the fact that 243 is in the denominator. 3 to the first power is 3. 3 squared is 9. 3 cubed is, if this is squares, it would be 9 times 3 is 27. 3 to the fourth power is 27 times 3, right? So we have 21. 3 times 2 is 6, plus 2 is 8. 3 times 5, right? Or 3 to the fifth power. And we're going to multiply this by 3. 3 times 1 is 3. 3 times 8 is 24. So there we go. So here, 5. So y must equal, we're saying it's 5. That would be correct if the 243 were in the numerator, right? That would be fine if 243 was in the numerator. But 243 is in the denominator. So instead of having a positive exponent, we're going to make it negative, okay? So y as actually negative 5. Because if we have 3 to the fifth power, I want to show you one more time. So we have this here, 3 to the fifth power, okay, is 243. However, if we had 3 to the negative fifth power, right, how do we make it so that this is positive, or so this exponent is positive? We have to take it downstairs, right? We have to take it to the denominator. So this is the same as 1 over 3 to the fifth power, which then becomes equal to 1 over 243. So see, that's why I had to make this negative, because this forces it into the denominator. So same thing, we're going to apply that same thought process over to the next one. So we have log of 1 over 216 base 6. 6 raised to what power is going to equal 1 over 216. 216 is in the denominator, right? Which means that we know that our exponent is going to be negative. So the end result, we know that's going to be negative. So we're going to ignore the fact that it's going to be negative for now. So off to the side, we're going to do some work. 6 raised to the first power is 6. 6 raised to the second power is 36. 6 raised to the third power is 216. We can see that we had the problem earlier, right? Right in the section before it. We know that 6 to the third power gives us 216, but this 216 needs to be in the denominator, so which means our power must be negative, our exponent must be negative. So y is going to equal not positive 3, but negative 3. So I hope that made sense. Feel free to reach out if you still have any questions. If you want me to make a video based on the exponent piece here and when to make it positive or negative, let me know and I'll put together a video for that. Anyway, thank you for watching and I will see you in the next video.